Hi everyone, thanks for coming. My name's Andrew Peters. I'm an engineer on Entity Framework team.
Okay. Today we are going to talk about, mostly we are going to do demos, and we're going to try to explain the demos and give you enough information so that you can use the new features and know when to use them, when not to use them. But before, we usually start with a slide that is about all the different versions and flavors that we have of Entity Framework because it's confusing, because we have like too many. First of all, we have two big boxes here. The one on the left represents, let's call it Entity Framework Classic. It's like the old code base that started more than 10 years ago. It actually has code from WFS in it. And we have been evolving it. We actually took it open source at some point, and it has been great to work on it. And we had many customers. We actually still have like the third position on the NuGet gallery.
Yeah, so how many EF users are here? Just as a quick poll, okay?
Julie, are you an EF user, really?
How many EF core users?
Yes.
Okay.
Okay. So we have like obviously less EF core users than EF users. But we started with EF core around 2015, more or less, because we realized that it has been becoming harder and harder for us to evolve the EF code base. We have a lot of complexity in that code base, and we have a lot of behaviors that we just need to keep because fixing them would be breaking change. And it has an architecture that leads to things like using a lot of memory. And we realized that we couldn't evolve it in a direction in which we could say, okay, now we have a product that we can say is mobile first and cloud first. So we decided to start from scratch. And it was a hard decision, but we are happy with the results. EF6 still has many features that EF core doesn't have, like table per type inheritance mapping, also many-to-many mapping without an entity in the middle. And I don't know, there are like, every day there are less and less features.
Designer.
The designer, yeah, the visual designer.
But on the other hand, worth pointing out that EF core also has several new features that will probably never land in EF Classic. So because we did the rewrite, it was a clean slate, we were able to architect it in such a way where we could add a lot of the things we've always wanted to do, but we just kind of built them in right from the start.
Yeah, we are pretty happy with the pace at which we are adding new features in the new code base. One of the features that we have, for instance, is batching, the ability to put several SQL statements for updates, inserts, and deletes into a single command and send it to the database so that you don't have multiple round trips, and it can be faster with latency. And another one is unique constraints.
Yep.
The ability to have like a key that is not the primary key, but you can use it to define relationships. And there are like many more, like the new features that we are going to demo today. They are not going to land on EF6, but
yeah, and performance is a feature. So
yeah,
we made things a lot faster in a lot of cases.
Anyway, if you're using EF6, the good news is that we are going to keep releasing it, and we are going to keep doing minor improvements. We actually released the EF 6.2 runtime last week. I hit the button. I was there when we did it. And this release in particular has many contributions from people that just wanted their feature, and they decided to just work on it and go through the whole process of getting it reviewed and improved until we check it in. And I want to thank all those people that do that. We also fixed a bunch of bugs that we knew about. And we are going to do more work. We already have planned more work on EF 6.3 even and on the tools, but this is a train that is going to move much more slowly than the one on the right, that is EF core. EF core was designed from the beginning to be lightweight, to be cross-platform, and that is the future. If you are starting a new application, we recommend that unless there is a killer feature that you really need and it's not there, use EF core. So some of the new features that we have in EF core 2.0. We have this theme that is about being able to run EF core everywhere. Everywhere there is an implementation of .NET, and the big effort that is happening on Microsoft, that was happening when we were developing EF Core was this Net Standard 2.0, which is this subset of the .NET API that you can run everywhere. And we decided to just target Net Standard 2.0 and leverage that so that we can run on .NET Frameworks 4.6.1 and up, .NET Core, of course, and Xamarin and Mono, and special versions that contain support for Net Standard 2.0. And we're going to continue with that theme in future versions. We had a bunch of new features. We're going to show all of them today, and all of the ones in this list. We have other smaller features as well. And we have some features that are about performance that we are also going to demo. We also made some architectural improvements. We improved how we leverage dependency injection internally to manage our own extensibilities and our own composition of services. We wanted to use less memory, so we moved some of the services that we had created to be singletons because they didn't really need to hold any state. And now that's improved, that simplified the provider model, but it changed the provider model, so providers for 1.0 don't work on 2.0, they need to be refactored. And we also rewrote a bunch of places in the link implementation to make it more robust.
Yeah, so we did a lot of work on the include pipeline, for example. And one thing that should come across with our demos is that one of our main themes as we build out new features and kind of consider what to do is to try and come up with features that are really cross-cutting. So sort of like low-level building block features that you can repurpose to be specifically for your application. So rather than, for example, complex types, we have a new thing called owned entity types, which we'll show you later, which is actually a superset. So that's kind of the theme.
Yep. Okay, first demo. Need to
switch it over, yep.
That's the one?
One.
You are on 2?
No, 1.
Oh, 1? Okay. There's 1.
It just takes a little while.
Okay.
There you go.
So the first demo is for compiled queries. If you have been following EF for some time, you are going to know that this is an existing feature from the first version of Entity Framework that we are bringing back into EF Core 2.0. Every time we execute a link query, we need to compile it. So the name is a little bit confusing. When we compile a query, normally what we do is we hash the link expression so that we can avoid having to recompute the compilation again every time we execute the same query. Like if you have a query in a request that for every request you are going to be executing the same thing, we avoid compiling that multiple times. We only do it once. But even computing that hash takes a little bit of processor time. So we have this alternative API that gives you a way to just say, okay, I'm compiling this query, now I want to execute it.
Yes, thanks, Diego. So the first couple of demos we're going to show are to do with performance. And this one is about eking every little bit of performance you can get out of query execution. So here we have a little program. It's using the AdventureWorks context. And here we just do a little bit of warm-up. So this first query is just about initializing the model, which is expensive, but then it will be cached. And then in here we have this run test method. And what this is going to do is just run this block of code a number of times and time it. So here we have our normal query. We're looping over some account numbers, and we're just executing a single query on the customer set, and we're looking for a specific account. So this is the normal style. Let's run it. Okay, so I think we did 500 iterations there, and it was pretty quick. It took 177 milliseconds. But what we can do is if we profile our app and we identify that there's a hotspot here in query cache resolution. So as Diego was saying, each time we see this, we go to our query cache and we look for an existing compiled query that we've already created for it. We can use a compiled query. And this is an explicitly compiled query. So instead of the query going into the cache, we're going to manage the lifetime of the actual compiled query ourselves. Got a snippet for that. So we can see here the syntax is a little more complicated, and that's why you wouldn't normally want to use this by default. But what we have is this EF static class. This is our main static entry point class. We call it EF just to be memorable and short. And any static entry point APIs are available off here. We have compile query, And this thing basically takes a lambda, which is the query we want to compile, and it's parameterized on a bunch of things. One is the context, so this is our context type, and then any number of parameters that the query should take. So a compiled query can have parameters because these are things that might change across query execution. So what we get back is basically a delegate, and it's just a func that we can run, which will run the query. So EF is not managing the lifetime of this thing. We have to put it in a static or some kind of field that will actually keep it around, so we don't need to incur the cost of a recompile.
My favorite pattern to manage compile queries is to create a static field on the DEVcontext, my derived DEVcontext class. I initialize the fields in place, and then I wrap them. So I create a method, an instance method on the DEVcontext that invokes this field that is a delegate, passing the first argument, that is the this argument, basically this DEVcontext, and then it becomes like super clean. It's like at least all the complexity of using compile queries is encapsulated inside the DEVcontext.
Yeah, so as I just typed, it was super easy to run it. We just invoke the delegate, pass it the context and the argument.
One question is, can people see this font from behind? Can you see yes or no? Raise your hand if you can see it. And raise your hand if you cannot see it. Awesome. Thank you.
So we ran it again, 500 iterations this time, it took 100 milliseconds. So always profile your app and understand what the performance is, but here you can get some good gains just by taking over the caching of compiled queries on the hot path.
So because it's so awesome and it's so fast, I should convert all my lean queries to compile query, right?
Not typically. As we said, you want to just measure, and you don't want to really be using the syntax unless you have to.
Yeah.
So we use it, for example, in like the tech and power benchmarks because it just makes a difference to the numbers we get.
Awesome. So the next demo is about another performance feature that we did that is called DEVcontext pooling. Let me switch actually for this one. Do you remember which one I mean? That's my daughter, by the way. This is weird. Okay. Let me hit F5 again. Now I can advance. So DEVcontext pooling. What happens, especially in an ASP.NET Core application, is that every time a request comes in, the ASP.NET Core MVC in particular is going to create an instance of the controller class. And if that controller class takes dependencies, one typical thing to do is to take a DEVcontext on the constructor. Then it needs to serve from the dependency injection component, it needs to serve instances of that dependency. And if I depend on a DEVcontext, then for every request, we are going to create a DEVcontext, we are going to pass it to the controller. And if you have 1 million requests, then we have been, after a while, we will have created 1 million DEVcontexts. When we profile this, we realized that we needed to make it really cheaper. So one approach we took was that refactoring of how we use DI and we made some things lazy so that we don't create the whole infrastructure that we need on the DEVcontext every time unless you start using it. But we also switched many of our services to singletons so that they are already created. But Andrew came up with this idea that we could also use pooling. And we say, well, we actually don't create a DEVcontext every time. We'll have a pool of pre-created instances, and every time a request comes in that needs one, we'll serve it to it. And we will never have to create that 1 million instances anymore. Let's look at how that works in the code.
Okay, so this little demo program basically simulates what's going on at a high level inside a web application. So we have a blog entity here. We have our context, and this context is instrumented here. So we have instance count. We're just keeping track of how many instances were created during the run. We have our blog set, and here's our blog controller. So we just have a simple async action, which is running a simple first async EF query. And then in our startup, we just do the normal add DB context at this stage. And then our program, spin up a bunch of threads and run for 10 seconds. So what we're timing here, what we're measuring is how many queries we can run per second and how many contexts gets created. So let's run it and see what our baseline is. Okay, so you can see we're getting through around 7.5K requests a second, but we're creating one new instance per request. So totally we create around 76K contexts. And even though they're cheap to create, they do have an object tree underneath them, so all of their dependencies. And this can just put a lot of pressure on the GC, for example. So the nice thing about pooling, what we did, is we implement it sort of in the configuration BI layer. So with one small change, we can do that. None of our other code needs to change. Our services will still depend on DB context. And what we've kind of installed here is an indirection into dependency injection so that the context will be served from a pool instead of always being created. Run it. So you can see here we originally spun up 32 instances, but now they're being reused and we're getting around 14K requests a second. So this can make a big difference in some scalability scenarios. We're just reducing a lot of stress on the GC and we're just avoiding doing a lot of initialization.
Okay, so if it is so great, why don't we just do it by default always?
So it's not enabled by default. So this feature comes with a few caveats, and the main one is that if you think about what happens when a pool is when a context has been used and then goes back to the pool, we need to reset it to a pristine state so that the next request gets it and it looks just like a brand new context instance. Now we know how to do that for all of the internal stuff that we manage, but any state that you might have added to your context, we don't know how to reset yet. So you need to be aware of this when you're using this feature.
Yeah, it's pretty advanced. So the next demo is about query filters. Query filters is I have a long story about it actually. I'll try to make it short.
Okay.
But we had many customers asking for a feature that we usually call include with filter. So it's the ability to say, okay, for example, I'm going to write this query that brings a customer into memory. When you bring the customer, also please bring me all the orders from that customer. But if you add the filters to that scenario, then it means bring me only the orders from, let's say, this year, not the old orders. And we could have created an API to do include with filters, but we thought that the API and the experience wasn't that great. And we thought that it could be better to do something more declarative so that you can put something in the model on the DB context to say, okay, whenever you query for this particular entity, apply this filter to it. And then it doesn't matter if it comes through an include or if you are querying for it, it's already filtered. Let's look at the code.
Thanks, Diego. So here we have a simple blogging context. And first, let's look at the query. So as Diego alluded to, we're running an include query here. So we want to bring back blogs and all of the associated posts. Let's go down and look at our C# classes. Okay, so we have blog and post. These look pretty normal. We have a navigation property here. A couple of interesting things. Post has this isDeleted property, and blog has this _tenant ID field. So what we really want to implement here are two features in our application. One of them is called soft delete. So rather than deleting posts when the application deletes them, I just want to mark them as deleted. And then multi-tenancy. So in the table for blogs, I want to store a tenant ID that allows me to partition the data. And this is a good example of where we've added a lower level feature, query filters, that you can sort of repurpose in application-specific ways to kind of achieve these higher level scenarios. So we have those defined. We can see that our context actually takes this tenant ID in. So whenever I new up a context, I can say which tenant it is for. Now, in order to realize this now, we need to just configure a few entity filters because what we want to say is that when we query for posts, we don't want to bring back the deleted ones. And when we query for blogs, we want to make sure that they're only the blogs for the tenant. So this is just a bit of Fluent API. So it's deleted first. So here's the new API in code first, model builder, entity of post, has query filter. And this thing takes a simple predicate expression as a lambda. So give me the ones that aren't deleted. Now our program just has inserted some data and is going to loop over these just to show us what we get. So you can see here, we're getting the blogs. We're still getting all tenants. We haven't implemented that filter yet, but we're only getting the ones that aren't deleted. So we implemented the soft delete just with that filter.
So what if let's say I want to create like an administrator dashboard or something, and I want to see the ones that are deleted and I want to undelete them. I need to still run a query on that database. Do I need to create like a separate DB context that doesn't have the filter, or is there a simpler way to do that?
So we added this guy. So being able to opt out of the query filters is what you might want to do in like an admin back office screen or something. So you can just call this a new link operator that we added, and it will just ignore all the filters you've defined.
Cool.
So the multi-tenancy one, let's bring it in. A little more complicated. Same kind of thing though. For the entity type blog, it's got a query filter. And it's basically the property on blog called tenant ID. Now we're using this special syntax here, using the EF static class again to address the tenant ID property. There's no corresponding property on our object that we can use here. So if we go back to blog, we've got a field mapping here. So we're only mapping this property to a field. So the way we refer to those things is we have that EF property method where we can use the string name for a property and still make it strongly typed, so we can kind of use it in link. And we want to check that the tenant that we're currently using is the one that matches the blog. So tenant ID on the blog equals the tenant that we've currently set on the context.
Okay. So that underscore tenant ID is a field on the DB context actually.
Yeah.
And this method on model creating is going to execute, and that's going to have a value. And this method only executes once, right?
Yeah, that's a good observation. So on model creating only runs once when your model is initialized. Now you might think that what this means is that when we add the filter into the model, that this tenant ID kind of gets hard coded to the current value of tenant ID for the time the model was being created. But actually we recognize that this scenario is like super valuable, so we do a little bit of extra work to kind of detect these field accesses on filters, and we parameterize them. So whenever the filter gets applied at runtime, we will actually get the current value of tenant ID off the instance that you're using to execute the query.
Okay, so if the value changes, we'll use that.
Yeah, that's right. And now you can see here, we're getting the right tenants back, and we've got logging turned on here, so we can see our query here. So there's the is deleted check, and then the tenant ID check here, and we can see that this is a parameter that we generated.
So next demo is about on types and table splitting. I also have a long story for this one. In EF, previous versions of EF in general, we had this concept of complex types. Complex types are types that don't have their own identity, and they are usually hanging from an entity. The most canonical example in the universe is customer address. The address it doesn't need to be an object that gets stored in its own table. It can be just a group of properties of the customer that, because they conceptually belong to the concept of an address, I want to have them together in an object. We wanted to implement and to support something like complex types in EF Core, but when we look at it, we realized that there was a way to implement it that could probably cover more scenarios than just complex types. And we created two different features that when you combine them together, they become a superset of what complex types used to be, but you can use them independently. So those features are on types and table splitting. On types is the concept that there is an entity type. It's still an entity type because in EF Core, all the types are entity types. But this one cannot exist by itself. It doesn't have its own independent existence. It always needs to be part of a graph of objects. It needs to be hanging from an owner entity type. And the identity that we use to track the object is always going to be a combination of things like the identity of the owner plus a navigation property that is pointing to this own type. And in the future, we are going to add the ability to have also a separate component that is its own key value when we add collections. The other feature is simply table splitting, which is I have two objects that have a one-to-one relationship, and instead of storing those in two different tables, I'm going to just put them in a single row in the same table. And I think that we're ready to look at the code.
Yeah, thanks. So here's our canonical example. So we have this customer entity type, and it has these two navigation properties, work address and physical address. So in EF6, we'd call these complex properties because the address thing would probably be a complex type. In EF core, these are normal navigation properties, and this is actually an entity type, just a special one. We're going to configure it a slightly different way. And here's the address. So here you can see there's no obvious primary key for this. It doesn't really make sense for it to have its own identity. If we run this now, what our program is doing is recreating the database every time and then trying to insert the data. Let me just switch the startup. Okay, so we get a crash. This is the famous, the entity type address requires a primary key to be defined. So this error is what you get when EF sees a C# object, C# type that it doesn't know how to, it doesn't have a primary key. It doesn't know how to figure out what the key is. We have some conventions for determining the key. If there was an ID property, we would have found it. But right here, there's nothing that obviously tells us there should be a primary key. So we don't actually want a key for this thing, so we're going to configure it as an own type. So here's the new API. We can say the customer entity owns one, and then an expression that tells us the property, work address, and physical address.
This is like an extension for our relationship to Fluent API. So instead of just has one, this one has a stronger semantics, and it says owns one.
That's right. So now we can run it. Okay, no error this time, that's good. And we've got the logging on it again. You can see the table that was created by default is using the table splitting as well. So on relational, by default, when we see an owned association, we bundle it into the same table as a convention, but you don't have to do that. Yeah. We'll show that in a minute. And you can see here we're using a column naming convention, so we need to disambiguate the columns, so we just prefix them with the incoming nav name, physical address. So there's city or town, and there's work address, city or town. And then everything is kind of set up as you would like.
Yep. So one of the advantages of building support for complex types in this way was that table splitting is now optional.
Yeah, so we can show that. So what we're doing is we're able to leverage all of the existing mapping capabilities that we have for entity types. So we can do a two-table here. So work addresses. And now when we get our database created, we can see the work addresses have been split out to that new table that we wanted. So we're able to separate them. So this is still like a complex type, but now it's landing in a different table, which you couldn't do before.
Yep.
So you can configure it in the same way you would for an entity. So you can address the property and then say has column name. That's one way. You could also use annotation on the property, the column annotation. So the question was, how do I customize the target column name for the mapping?
Yep.
So it's the same as with entity types. You can always override our conventions by applying more fluent configuration code. But the usual pattern is that you don't do that. You do that exceptionally when you find a difference in your schema that you need to address.
So another advantage of the way we build this is that these navigation properties are real navigation properties, and you can refer to them in link queries, and you can also have navigation properties from a known type to a completely different entity. So one case here is that we could make the country become a real entity instead of just being a string.
Yeah, so something you couldn't do before with a complex type was have an outbound nav from it to an entity. So you can do that. In this case, for example, we could have an outbound nav to country here, make country a first-class entity type.
Yep. In EF Core 2.0, we only support references to own types. The plan is to eventually support also collections of own types. And when we do that, I think we are going to have a pretty nice representation of aggregate from DDD. We are still working on some details for some things on DDD that we don't support, but in general, the owner is going to become the aggregate root, and then any other object that is hanging from a collection of own types or a reference is going to be leaves of that aggregate. Yes.
Yeah.
Yeah, you can
So
have
they can be
nested own
nested.
types. So the next demo is about functions, function mapping. This is a feature that got contributed by a guy that's called Paul Middleton. He was really patient, and he went through all the pain of getting his code reviewed, and I always congratulate him for doing so because he got like a major feature in EF Core 2.0.
It's not that hard, right? Everyone should try and contribute.
Yeah, don't necessarily try with the hardest thing, but we have many things that are up for grabs in our repository, and anytime you want to have some fun with us, we are actually fun people. We are going to make comments about your code that are very fun.
So, yeah, DB functions were really designed to be a way to allow you to easily invoke existing or new database functions that you might define from within your EF Core link queries. So here in our example, we have our blogging context again. We create the database, and then we run a little bit of ad hoc SQL here as part of that process to create this function. So this compute post count is just either a function we already have on our store, or maybe it makes more sense to define it as a store function. So we do that. Now we want to be able to call this thing. So what this feature allows is that we can, on our context, essentially create a stub here. So this compute post count is something we can reference in link queries. And what will happen is if we configure it a certain way, our link compiler will actually just turn it straight into the function call in SQL. So the way we configure it in this case is by using this annotation. You can also do it in on-model creating using the Fluent API. And by default, we'll use the name of this stub method as the target store function, so compute post count. If it was different, then I could call it out in here. We've got a function name property we can override the convention with. Okay, so what does it look like to call it? As you would expect, I can just do a query, blogs, select, and then invoke our C# method. Can take a parameter here, it's taking the blog ID in. Run it. And here you can see we just generated that nice SQL invoking the function for every blog, passing it the ID, and printed out our output. This is just another example of being able to kind of set up flexible mappings to objects in your store and then reference them from a nice sort of C# programming model.
Yep. One of the limitations in EF Core 2.0 for function mapping is that the method needs to be a static method. We have actually Paul, the same contributor, has removed that restriction in our current build. And we are planning to do more things. Hopefully, we are going to get support for table value functions mapping directly to a method. And there are like many exciting extensions to this.
Yeah, another one we've talked about would be you can define this function on an entity class itself. So for example, if it was defined on blog compute post count, when we translate it, we would basically turn this reference that you've got, b.postCount or compute postcount, into the ID. So we would pass the ID through to the function call. It's just a way of getting more expressive on the C# side and then having a way of kind of mapping that down to some reasonable translation on the store.
Yep. So this is a great approach for custom functions. We also had some improvements on what we call built-in functions. The idea of a built-in function. Did the audio go out? Okay. The idea is that you can have a function that, for instance, is supported by a specific database provider or a specific database engine. And you want to create a stub so that easily customers that are using that provider can access that function. So we have this ef.functions API. Is a property on the ef static entry point. And you can define, if you are a provider writer, you can define extension method. Anyone actually can define extension methods on that instance so that people can use those functions in queries. We kind of bootstrapped ef.functions with our own like function that translates to the like operator in relational, but can also execute in memory or can translate to something else in some other database. And we are going to show that, right?
Yeah, so here we have a blog service, and this is a component that we wrote in our application, and it depends on a context. And it just has a little domain method here, or a search method, search blogs, that basically results in a link query. Now this is the functions property that Diego was talking about. This lives on the EF static class, and it basically serves as two things. It's a place for us to put common functions that we think can be implemented across most stores, including in memory. And it also provides an extension point for providers to hang provider-specific functions as extension methods. When they do that, their provider can actually see that function in a query and turn it into some provider-specific behavior. So in this case, it's one that we define. It's the most common one, like, so it maps to the like operation in SQL. But the way it's defined is that it has an in-memory implementation as well. So if you went to the definition of that method, you would see that we actually implemented it. And the reason we did that is because we have this cool thing in EF Core, which is the in-memory provider. And this allows us to write tests that don't need to go to the full backend. They can just use the in-memory provider, and it's much faster. But you can still have all the full capabilities of link and all of those things. Save changes will work, everything will work. It's a good way to write that style of test. So we have this test here, which is testing our service, and it's invoking search blogs, but it's actually using in-memory. So we can write a test like that and run that. So that passes. So it's just an illustration of kind of a difference in the way queries get executed in EF Core, is that often you can run them against in-memory stores. You can have client behavior that's intermingled in the query, and you're not going to as often run into this query could not be translated because I didn't understand this thing. We're trying to make it very extensible so that providers can add things, we can add things, and it ends up getting you to where you need to be. So this is a custom thing that we built, which is very lightweight. It just uses basically dictionaries underneath, and it basically shreds out the entities, puts the stuff in memory, and you can think of the query side of it as this link to objects. Effectively, it's doing like link to objects over this data that we're storing on the side. So it's really mostly for testing, but it makes a lot of testing scenarios a lot faster and easier.
Would you like to do string interpolation? I think we have time.
You think so? No, I think we should.
Okay. Okay, we are going to try to switch directly to this slide. No, but you are going to see my daughter again. Doesn't work. Sorry about this. Okay, this slide. EF Core 2.1, we're going to show some of the new features. They are in a very raw state because we are not done. This release 2.1, we don't have a completely clear target date for it, but we know that it's going to be first half of next year. We're going to have a preview before that, obviously, or 2 or 3 if we get away with it. Many of the things that you are going to see here are like top voted requests from the community on things that we should support, like group by translations and things like data seeding. We also have some interesting innovations like view types. It's not that groundbreaking, I guess, but this is about the ability to have an entity that doesn't have a key, so that is read-only. It can map to a view or a table that doesn't have a key. Include for the right types, that is like a long-standing ask from the community. System transactions, we are going to be building a Cosmos DB provider. We actually started already the work on that, and we built a sample Oracle provider. The idea of this sample Oracle provider is to help accelerate the effort from Oracle and any third party that wants to support EF Core. They can take our code. It's licensed as open source, so they can use it as a starting point. Andrew also did some work on App Insights integration. That means that when you are running a .NET Core application and using something like SQL Client, you are going to see the right events whenever there is a query sending SQL to the database. And you're going to be able to visualize SQL Server as a dependency when you're running on .NET Core. Not completely related to EF, but it's important work that took a lot of effort. We are doing lazy loading. Who here likes lazy loading? Few people. Who here hates lazy loading? Almost the same amount.
Same people.
Oh, was it the same people? Okay.
It's a love-hate thing.
Yeah, this is lazy loading. I think is the top voted thing that we have on the repository.
Yes.
We also did some testing of UWP. They released a new version of UWP for .NET that supports Net Standard 2.0, and we wanted to make sure that EF Core runs correctly on that. And EF Core 2.0 happens to not run correctly, but we are going to be releasing a patch very soon that fixes all the problems that we found. First demo is view types.
Ooh. Yeah, so we have 2 ways, I guess, of showing this. We have nightly builds. Some of the stuff is in our nightly builds. This one is not. This is what we call a bootleg build. So what we have is another little sample program. We have an orders context. So this guy just has customers. So we're creating some customers, some products, and some orders. So Diego has ordered 12 empanadas, and I've ordered 20 meat pies.
So actually, I'm feeling hungry right now. So can you?
Okay, we always have this. Okay.
Yeah. Thank you.
There you go.
Well, that's too much.
And we're running some custom SQL here to create a view. So this is another common thing we hear a lot about is how do I map to a view? Now you could always map to a view with EF. It just wasn't very intuitive because you would call something like toTable, and it kind of implied that this thing needed to be a table. EF doesn't care whether the thing you put in toTable is a view or a table. It's just the thing that we're going to plonk in the SQL when we generate it. So you could always define it. The downside was that you have to define a key, and quite often if you're mapping to a view, you might not have anything that's a sensible key that you can map to. Now EF needs a key usually because a lot of the time you're tracking the results and you want to save changes, you want to update these things. So we use the key obviously for that. But what we said was we want to just have the ability to create like a read model. Doesn't depend on keys, so these things aren't tracked, but gives you more flexibility in the shape of the entity. You don't need to define the key. So here's our proper entity types. We're going to create a few things to get this view type to work. First, we need to define the C# type. So this is the actual C# type that we want to be able to query. So this is the order view. Doesn't have a key, doesn't need to have a key. Then we need to do a little Fluent configuration to tell EF Core about it. So that would be a proposal for the new API. We haven't fixed on any of the naming here yet. I wrote this kind of prototype stuff, so I get to call it view types at the moment. But what we do usually is towards the end, we get in a room and we just argue vehemently about what it should be called.
Yeah, if you have ideas of what we should call this feature, send us comments on GitHub. That's going to help a lot.
Yeah, and you can see even somewhat confusingly here, we have this toTable API. So this is leveraging a lot of the existing code that we have for entity types. And so again, it's a place where the API is called toTable, but we're actually going to map it to a view in this case. So it's not really a table, it's just, this is the database thing that this maps to.
It's basically the table here is just the thing that goes in the from clause.
Yeah.
That's it.
And then we need some analog of a set. So this allows us to actually query this thing in a nice way. So we have this DB view, like a DB set, but read-only. Order views, and then right now we're just calling the underlying view method because we don't have this automatic initialization thing that we do for sets yet. Okay, so that's that. And then now we can just query it. So just loop through all the views. Okay, great. So here's the important bit. We just were able to generate a query against the view, and we were able to define the C# object that we wanted, the view model type object.
Yep.
Now this is nice too because as I said, we're reusing a lot of infrastructure. We expect that these view types should be able to have rich mapping capabilities. So for example, you can define an inheritance hierarchy of view types, and as long as you configure a discriminator, that mapping will just work. Or view types could have navigations to entity types, for example. So you can think about defining a view model that has some references to your entity types. It just gives you a flexible way of creating C# types in the way that you want.
Yeah. Another thing that we are thinking about doing for view types is actually an orthogonal feature that becomes very useful with view types is the ability to have a defining query on the model. That means that when you are defining an entity, for instance, a view type, or it could be a normal entity, you can also say, okay, instead of mapping this to a table, use this, let's say this SQL to create an instance of this. Like, don't go through that table, just use the SQL that I'm giving you. Another thing about this feature is that it's going to be a building block for something that is also a top request, which is the ability to do raw SQL queries that materialize an arbitrary type. So for instance, you want to do a from SQL call, but then use a type that is not defined as an entity in the model. This is going to become a way to do that. So the next demo is data seeding.
Okay, switch to that.
This feature was also initially implemented by a person that is not in the team. He was one of our interns. His name is Martin Cole, and I'm very grateful to him. We really only needed to do some minor improvements after he left.
Yeah, I mean, do you want to describe how seeding worked kind of before?
Yeah, the idea of seeding is that you have the ability to pre-populate a database with reference data, for instance. That's the most common thing that you would do. In EF6 or previous versions of EF, even we had data seeding, but it was very imperative. It was basically there is a method in which you can play on DB context and add anything that you want to it. And there was an extension method that Andrew wrote. Actually, I remember it was you.
Yep.
That is add or update, that you pass the data and the method will query the database. If there is an entity already with that data, then it will just make updates to it. If there is no entity with that data, it will do an insert. But that wasn't like super efficient, and it was really complicated because you needed to always keep that method up to date with the schema of the database and the new shape of your object. So we chose to step back and rethink how we do data seeding. And somebody in the team, I think it was Bryce, came up with this idea that we could do something more declarative, that we could say, okay, the seed data is actually part of the model, and it participates on model diffing. So whenever migrations needs to come up with a set of statements to update the database, it can also generate the statements to update, delete, or insert seed data.
Yeah, so we have a blog here, and we introduce this theme entity type. So our blogs are themed, and we want to initialize the themes. When we deploy this thing, we want to have some themes already there. So you can see this is a new method in on-model creating, seed data, and this is the first time where we've actually said you can associate data into your model during on-model creating. So we're defining some seed data for themes. We can just new them up in the normal way, set their properties, and they'll be in the model. And what that means is that they now get to participate, as Diego said, in every stage of kind of schema construction. So what we're going to do is actually add a migration just so we can see what happens. We don't have a database yet. Let me... All right. I'm adding the initial migration. Okay. Jump out of there. Should be over here now. Okay, so here's the scaffolded migration for the initial create of the database. So we're creating the table themes, table blogs, got all the columns, constraints, all the usual stuff. And then here's the new stuff down here, is that the differ detected the seed data, detected that it was new, and generated these insert API calls. So we're sort of versioning, managing the seed data along with the schema object. So we could apply it or script it out. I'm just going to type script migration. So what this will do is generate a SQL script based on that. And we can see here the DDL, but down here we should see some insert statements.
Yep.
So these were generated along with the DDL.
You're going to notice also that we are doing this set identity insert on. That's because in SQL Server, if you declare a column as identity, you cannot update it anymore unless you do this. In the seed data definition, you have asked for a specific value for the key. And in order for us to actually make the value of the key on the table that value, we need to alternatively set identity insert on, and then we turn it off every time.
Okay, so I just applied it. So now we have the database set up. I ran update database because we want to show I can run it and it's printing out the themes. Now the real benefit of this approach now is, and what was harder before, is now our application logic is changing. So we're going to make a change here to Alice Blue. We're going to add migration, Alice. Here it is. So now we just have this update data call, both up from red to Alice Blue and down from Alice Blue to red. So you can see we're really versioning the seed data here, managing it in the same way. It's kind of easy to understand.
Can we show the SQL for this?
Sure.
I think you can do
script,
and then if you want, you can do from migration initial.
Oh yeah, I'll just script it all out, I guess.
Okay.
So when you call script migration, by default, you get a script for the whole database for all the migrations. So we get the first script that we saw. Did it create a new one? Let's try it again. And here we go down here. The second migration generated the update.
Okay, we have another couple of features that we want to demo, value conversions and group by translation.
Yeah, so these ones are super new, not available yet. But we just thought, because we're making some progress, we'd give you a sneak peek.
Yeah, these are available in nightly builds, right? But no, not in previews.
Yeah, group by is available in nightly builds, and then kind of value conversions are half done. And do you want to just talk about what value conversions are about?
Yep.
Yep.
So value conversions is this idea that the types of the properties of your objects don't need to match types that are supported natively on the database. So far, what we had in EF Core was we only support the types that the database supports. So one example of something that is not supported is unsigned integer types on SQL Server. If you are running a database on a database that supports unsigned integer types, everything is fine. But if you try to do it with SQL Server, the SQL Server provider for EF Core knows that those are not supported, and therefore when you are creating the model, it's going to give you an exception saying that it's not, we couldn't find a way to map that property. So one thing that we are doing a feature that actually solves that problem, but also allows custom mapping. The first part of it is basically saying, okay, we add a bunch of converters that we can apply whenever we see a type that is not natively supported. We can find the next possible mapping for it. For instance, for unsigned types, for many of them, we are just picking the next signed type that is wider so they can hold the value. We can imagine that in the future, for some types, the best conversion could be a string. We'll just put this serialized as a string. But the next phase that we are going to be working on for 2.1 is to allow like complete customization of the mapping. So you are going to be able to write like 2 lambda expressions saying, okay, whenever you need to materialize an object based on this column, do this conversion. And whenever you need to send it back to the database, this other conversion that is the reverse. And one of the ideas that we have is to test this feature with encryption so that you can do like transparent encryption without relying on a specific database.
Yeah, and this feature really helps when mapping to databases, for example, Oracle. So I don't know how many people use Oracle here, if anyone, but one problem you might run into is like, how do I map Boolean to like Oracle? Like they don't have a Boolean column type. So you either end up using 1 and 0 or like Y or N, or there's various like conventions that Oracle users have kind of come up with. And so this really like encapsulates that into a thing that EF Core can understand. You know, let you pass us 2 small pieces of code that deal with that conversion on model creating maybe, and then we will just call those pieces of code to do the kind of ad hoc conversion. Mm-hmm. Pretty powerful. But that's not all built yet, but what we do have is kind of the ability to, as Diego said, use some of these more esoteric types that weren't able to map before. So here we've got the blog theme example again, and we're just mapping the key as an unsigned int. Now we generated a migration for it, and when we ran it, we can see here that what EF actually generated was a big int. So like Diego was saying, we have a bunch of rules for choosing what is the best candidate target type for one of these things that's not natively understood. SQL Server doesn't have a good native type representation for this, but we can find a target type that will work for it. And as Diego kind of alluded to, it could even be like you just drop back to using strings for things that just are able to serialize, and you write some small serialization code that reads them and pushes them in. We wanted to show another quick example of something we just got working. over this. So here, we're going to loop over the themes and we're going to do a group by. This is something we got a lot of feedback on. We didn't have support for it in V1 or 2. The main reason is that the group by operator in LINQ is actually a lot more powerful than the one in SQL. So there's only a very small subset of translations that you can do, specifically translations that look kind of like this, where I do a grouping on a key and then I do some aggregate function. So this kind of very much corresponds to the SQL group by. So this is what we got working for 2.1. So as usual, we generate kind of nice EF core SQL, do the group by, project out the count and the key.
I hope you like it. So many people have asked for it. So we have some. Do you want to do any other demos?
No, I think we're here. We do questions.
Okay.
We'll wrap up.
It is at the video driver again. So let me show you the whole deck again. This one. Okay, so these are some links to interesting things that you can find. All the code for these demos are maintained under Andrew's account in GitHub. Our main project repository is Entity Framework Core under the ASP.NET organization in GitHub. We have our documentation in the docs.microsoft.com EF website, and these are our Twitter accounts. We have an official Twitter account for EF that is called EF Magic Unicorns, thanks to Hanselman that gave us that name. And we have our blog. It's actually the .NET blog. We usually post any announcements there. And
yeah, so like we're on GitHub. We always encourage people to come file issues against us. Pull requests are always welcome. We're very open to participation from everyone in the EF community. It's all about listening to you guys and figuring out what we do.
yep.
Yeah, so the question is, what's the best way to provide this feedback and issues? Yeah, just go to our GitHub, look for an existing issue. A lot of the ones you'll run into have existing issues, so then you can comment on them or put the thumbs up or whatever. Otherwise, file a new one. And we sort of triage those every day, and those kind of bubble into our backlog of what we want to work on.
Yeah. Even if you find like an existing issue that represents more or less what you want, if you think that you have like a unique scenario that you are thinking about solving with that feature that you're asking for, write it down in a comment, explain it to us, because it's always helpful. Yeah, sure.
I'm curious on the link expression, like when does that comparison run after?
That's a very good question. We actually are discussing this because there are conversions that are not going to preserve order comparability. Typical thing is, say, I have an integer and I want to represent it as a string, but I don't do padding. So now 11 looks like greater than 2. Or sorry, the opposite. 2 looks like greater than 11 if I do just a string comparison. So what we are thinking about doing right now is that we are going to have an API to tell us that you care about order comparability for that property. And in that case, if we are going to choose between any of our like already built-in conversions, we are going to pick one that preserves order. So in this case, it would do padding with zeros or spaces. It doesn't really matter. And if we cannot find a conversion that preserves order comparability, then we are going to switch to client evaluation to do the comparisons in memory so that they still return correct results. Okay. So in EF Core, we do batching, which is not as fast as SQL bulk copy, but is faster than doing individual SQL statements for each row. One thing that we had in the backlog is to use TVFs. It's another way that you can, sorry, TVFs, not TVPs, table value parameters, which is a way to say, okay, I'm going to stream up to the server all this data that needs to be inserted. And on the server, I can just have a single statement that takes all that data as if it was a table and inserts it. I don't know that we would go as far as writing something custom that uses SQL bulk copy because it's like a completely separate API and it's very specific to SQL Server. But we have things in the backlog to make it faster if it is necessary.
Yeah, and I think what we've seen and what we would hope for something like this is that the community produces some extensibility for EF. So I think we had this before. We might even have it for core, where someone in the community just built out a SQL bulk copy capability. We are encouraging the ecosystem to fill in the gaps. We kind of designed the architecture to be more extensible so you can plug in different places and reuse pieces.
Yeah.
Yeah, I mean, I think it's fine. It's obviously valid in at least one scenario here. So my presumption is that you want to reuse your C# classes and all of the mapping that you defined. But then you just have a job where you're like trying to pump in and initialize some big database or something.
You created one. Okay, awesome.
So I think the question is about would we support mapping to JSON columns? And yeah, I mean, we're actually looking at that at the moment with Cosmos DB. So Cosmos DB is in one form a document database where you deal with JSON. Yeah. So what we generally try and do is if we built out that kind of capability, we would try and figure out how we could apply it across any providers where it made sense. So part of it is value conversions, and part of it would be what kind of sort of representation of the JSON do you want in your C# class? Like, are you happy getting like a JSON.NET object in there, or are you actually wanting it to be like serialized into some POCO object model? So those are kind of the questions we would, love to hear your thoughts on.
Yeah, actually supporting JSON mapping is one of the top voted issues on GitHub for us.
Yeah.
One problem that I have with that is that it actually means different things to different people. And if you could write down like a comment on that issue, that you are going to find it very easy. Just search for JSON in our issues. You are going to find it. It's one of the top voted ones. And just write a comment there explaining what it means to you, because that's going to help us decide not only the priority, but also what exactly to design. Because it's believe it or not, it doesn't mean the same for everybody.
Yeah, and I would anticipate, like, at least with value conversions, there's something rudimentary you'd be able to do.
Yeah.
I mean, it might not be fully baked or first class, but you'd be able to at least round trip the data to and from.
Yeah, the thing is that databases tend to have like special functions to handle them that then we would need to support in Link probably to have a good experience. So.
Yeah, that's the hope with the value conversion stuff, is that whatever code that you write, we're just going to invoke it. Yeah, I think lazy loading of non-navigations is another thing we want to do, because it's that exact pattern where you don't always want to load all of the columns for an entity. And so with the lazy loading work we're doing, I'm hoping that it's not just around navigations, but we just kind of cross-apply it to any property.
So I wanted to do something earlier when everybody was here, but I'm still going to do it with you guys. Tomorrow at 10, I believe there are like many interesting talks. One of them is Julie's talk, right? It's at 10, right? Okay. She has a very interesting angle. She's going to also talk about EF Core 2.0, but she has a different angle. And I think it's going to be very helpful, especially if you are coming from EF6 and trying to understand what is different about EF Core and try to start on it. Her angle is really great. Julie Lerman, you don't know her.
Yeah.
Yeah.
So it'll be all about how on earth do I use all of the stuff I just saw yesterday.
Okay.
Thanks.
Thank you.